I've made connections that will last a lifetime, hopefully, and I'm really excited to see where those connections continue to grow and develop.
The idea of the workshop was to bring together students, postdocs, even some junior faculty who all have a shared interest in using simulation, using computational techniques and tools and software to support their biomedical research.
The goal of this workshop is to integrate a lot of the software that we've developed on the ski side of things with the software that, for instance, Rob McLeod uses for bioelectricity simulations and the software that we use for computational biomechanics. And so try to put together a pipeline so that we can go from images all the way through to simulations and post-processing.
We're trying to kind of indoctrinate a new set or a new generation of simulation scientists. The philosophy is that if we can get across sort of a bunch of both fundamental ideas in imaging and geometry and numerics and simulation, if we can get across fundamental ideas and then combine that with some training in how to use software tools that implement those ideas, that these students will be particularly well prepared to conduct the next generation of sort of realistic biomedical simulations.
The common theme to all of this software is trying to make the life of researchers easier, because oftentimes we as scientists deal with data complexities, and the challenge isn't in processing data, although there is quite a challenge in that, but it's visualizing it and conveying it in a meaningful way so that others can understand and appreciate what's happening.
The unique feature of this particular course, which is really a 2-week-long course, is that we have enough time to provide the background, to explain where the algorithms come from, some of the ideas behind the algorithms, some of the basic principles behind the elements that make up a complete set of tools that anybody in this domain really has to know how to use. And then we can add on top of that basic understanding, specific knowledge of the software tools that we produce here in the Ski Institute.
What I do, I work on the project called epidural stimulation. So we work with people that have spinal cord injury, for people that can't walk. So the main idea, the overall idea is to make people walk again. So for instance, our first subject, he was out for 3 years. So we did this project, the epidural stimulation. We implanted a device on the spinal cord. First time we turned it on, we told the subject to move his leg, and he was able to move it after 3 years without moving anything. So if I create a model and I can predict which nerves I'm stimulating, that way we can make the whole project more efficient.
The plan is to do a whole heart electromechanical model and to do it patient specifically, so not only personalized anatomy, the biomechanics and the active stresses within the heart, but also the circulatory components, as the heart is connected to the circulatory system obviously. And at the moment I'm just working on the left ventricle, but I want to extend it to the whole heart and include all the other chambers as well.
Two different groups that came together to put this course together. One group is called the Center for Integrative Biomedical Computing, the CIBC. And then there's another group, the Musculoskeletal Research Lab, or MRL. And each one of these groups has developed independently their own software within the Ski Institute. And we decided that bringing those two groups together could provide a really comprehensive and powerful set of tools that a lot of biomedical simulation researchers can benefit from. And that's how we've really structured the course.
I was really excited about this workshop, and coming into it as a clinician, there are several real-world problems that are difficult to answer. And as an engineer, we have a set of tools and resources at our hands, and this workshop has helped expose me and introduce me and teach me several additional resources to help model, to help answer, to help in the clinic to address real-world problems. And I'm really excited about the opportunity to bridge the gap between clinicians and engineers.
I think the workshop was really interesting and I learned a lot. But also the afternoon activities, I mean the area, I love the outdoors, so I think this is definitely the right spot for me.
Youth at school.